How's it going, guys? My name's Josh Contreras. I'm a game design student, and the topics I'll be covering are electrical circuits, gravity, and a small example of inertia. And this is for Raul Vargas's class, and let's get started. Since I am majoring in game design, I figured what better way to show physics in a game than by physically showing it. What I have here is Minecraft. It's an Xbox 360 game, and I set up a little course here to show how physics can be used specifically in this game. Right here, I have circuit number 1 as a series circuit. The red stuff on the ground here is redstone. It acts as a wiring source, and this lever here is like a light switch or a power source of such. As you can see, when I flip it on, the wire lights up to show that power is traveling through. These things right here are known as repeaters. Obviously, when power is running through them, you can see that they're lit up. Show you again one time. Not lit up. Lit up. And what I wanted to prove here in the series circuit is that if I were to take out a piece of the wire in here, as you can see, I lost power to the rest of the wire, or the rest of the sources past that wire, because of the fact that it's a series circuit and it's all connected. If I were to replace the wire, as you can see, power is restored, and this was my example of an electrical circuit, my first one. The second example I have here is circuit number 2, which is a parallel circuit. As you can see, same concept. The redstone is used as the wiring, and the repeaters are used to establish whether power is passing through them or not. This is actually a parallel circuit example from our lab that we had done. When I turn the power on, as you can see, power is flowing through the entire wiring system. If I were to take out a piece of the wire here, as you can see, the rest of it is unaffected. The only thing affected is the repeater in the middle. There's still power going here. As you can see, it's lit up, and this one isn't. If I were to replace the wire, power would be restored. And the same for this example. If I were to take out a piece of the wire, the power is lost to this repeater, but this one over here still has power flowing through it. I replace the wire, power is restored, and this is my example of a parallel circuit. And I know these are kind of blunt examples, but I mean, the main focus of this redstone is actually, on a much larger scale. If you think about it, you could use this to wire your homes. As you can see, there's a few houses built over in that region. You could use the redstone to wire your homes with switches and buttons and that sort of thing. Another example that I wanted to get into was gravity. A lot of people perceive video games to be this fantasy thing that us gamers like to, go off into our own worlds, but we thrive as gamers on games that perceive reality very well. What I wanted to prove here was, obviously, if I were to jump off this and gravity was not in effect in this game specifically, I would be able to fly or go across the land in a different region. But if I jump off this, as you can see, I have 10 hearts above my inventory, right to the left of which looks like the ham bones. Gravity and falling from a height has a human factor in this game, a reality factor of physics that gravity is intact. So when I jump off here, as you can see, I fell to the floor, slightly hurting myself. And I fell. I didn't float in space because gravity is intact here. This one, what I have right here, is called Run, Run, Run. What I wanted to show is that at rest, I'm at rest, I'm not moving. Inertia is an object at rest will stay at rest unless acted on upon an outside force. And when I'm sprinting and I stop sprinting, my body, my guy also stops too. And I wanted here to prove that inertia takes place too. The force of gravity, the force of the friction on the ground, the cobblestone slows you down and puts you to a stop. And this is my physics video example. Thanks, guys.